In this video, I'm going to explain how the properties of exponents apply to products and quotients raised to powers and powers raised to powers. Take a look at this example, x squared cubed. Remember that that cubed just means that whatever quantity is in those parentheses is going to be multiplied by itself 3 times. So that means that we can write this as x squared times x squared times x squared. At this point, we can expand again, writing each x squared as x times x, giving us x times x times x times x times x times x. Now x times itself 6 times can be rewritten as x to the 6th. Notice that the two exponents in the original expression, when multiplied together, give that exponent 6 in the simplified expression, meaning we don't have to write everything out like this every time. We can just multiply the exponents when a power is raised to another power. Let's take a look at another example. Suppose we're working with an expression that has a product of two terms with different bases raised to exponents, all raised to another exponent. Let's write this out and see what happens. Remember that multiplication is commutative, meaning that even though these terms are separated into 3 different quantities, we can really move these 6 terms around freely. That means we can group the 3 x to the 5th terms together and the 3 y squared terms together. Using the multiplication properties of exponents, we can simplify this to x to the 15th times y to the 6th. And then looking back at the original expression, you can see that raising that whole quantity to the power of 3 means that that exponent 3 applied to both x to the 5th and y squared. The product of 5 and 3 is represented in x to the 15th, and the product of 2 and 3 is represented in y to the 6th. Let's look at another example of this type. If a quantity that has a coefficient is raised to a power, that power applies to the coefficient in just the same way. So in this example, the coefficient 2 will be raised to the power of 5, giving 32, and the term x cubed will be raised to the power of 5, giving x to the 3 times 5, or x to the 15th. Similarly, in a rational expression like this, with both numerator and denominator raised to powers, and then the whole quantity raised to a power, that outside exponent will apply to numerator and denominator in the same way. Now what if we have a term raised to a power, raised to another power, raised to yet another power? How does that third step play out? Take this example, x to the 5th cubed, then squared. We already know that those two inner layers, x to the 5th cubed, is going to turn into x to the 15th. Then the squared can just apply in exactly the same way, giving us x to the 30th. The takeaway here is that if you have a term raised to a power, raised to another power, raised to another power, for any number of steps, you can simplify that by finding the product of all the exponents and using that as the exponent for the base. Let's look at another example of that type. In this last example, I'll write an expression which includes all the properties we've talked about, the division and multiplication properties of exponents, as well as powers raised to powers and quotients and products raised to powers. I suggest you look at the example, pause the video, try it yourself, and then compare your work to mine. That's it for properties of exponents as they apply to products, quotients, and powers raised to powers. Thanks for watching, and I hope this helped.